a lock and fit model. In this lock and fit model, so lock and fit model. In this lock and fit model, the substrate enzyme, the substrate having specific shape and enzyme having the corresponding shape of the substrate. The enzyme having corresponding active site of the substrate. Therefore, the enzyme active site is the same shape of the substrate. Therefore, the substrate locked here the active site. Therefore, this is called lock and key model. In this, enzyme act as a lock and substrate act as a key. Okay. Next, induced fit model. Induced fit model. So in this case, that substrate active site, the enzyme active site is not suitable for the binding of substrate. Therefore, when this substrate approaches to active site, when the substrate approaches active site, this active site of the enzyme undergo reorganized to the corresponding bonding corresponding size of the substrate. Therefore, that undergo reorganization of substrate active site, then they bind the enzyme in the molecule. So next one, three-point contact model. Here, three-point contact model. In this three-point contact model, so here 3 point. So substrate enzyme having 3 points to substrate bind the substrate of the molecule. So here we take these 3 points in the active site of the enzyme, and these 3 points are helped to bind the substrate molecule in the active site of the enzyme. Okay, this is a three-point contact model. This is a very, very important. This is a very, very important mechanism of enzyme catalysis. That is a lock and key model and induced fit model, 3-point contact model. These 3 are the very, very important in your examination. So next one, coenzyme. Next one is coenzyme. So all known enzymes are proteins. Some enzymes are simple proteins molecule and some are conjugated proteins, which are associated with the non-protein part of enzymatic activity. Such enzymes are called as halogens. These are called as aprotic coenzyme. This is called as coenzyme. So best example here, we will take zinc +2 carboxylate peptidase A is carboxylic anhydrase, and iron +2 is present in hemoglobin. Copper 2 is present in peroxidase enzyme. Next, classification and nomenclature of enzymes. Classification of nomenclature of enzymes, very, very important. Classification of enzymes. The enzymes have been classified into 6 major classes on the basis of reaction catalyzed by them. Each class in further subdivided into subclasses. The majority of the classes of enzymes are oxidative reductases, transformases, hydrolysis, lyases, isomerases, ligases. So first we are going to oxidoreductases. So that enzyme, these enzymes catalyze the biological oxidation and reduction reactions. These are energy yielding reactions. These are further classified into subclasses. That is dehydrogenation. They catalyze the remolar addition of hydrogen atoms, and oxidases. These are catalyzed by the addition of oxygen. Oxygenases catalyze the incorporation of oxygen into the substrate. Oxidative deamination. Oxidative deamination catalyze the oxidation of amino compounds with a formation of NH3. Hydroxylation, introducing of OH group in a substrate. Peroxidases, use of hydrogen peroxide as a oxidant. So these are some examples for the oxidoreductases. Next, transferases. These are the enzymes which catalyze the transfer of chemical group like alkyl, methyl, carboxylic acyl, formyl, glycosyl for phosphate groups from one substrate to another substrate. So here, here AB present in one substrate and CD present in one substrate. When in the presence of transferase, A is transferred to this group and C is transferred to first substrate. Like this transferase takes place. Aminotransferases here. Aminotransferase means amine groups transfer takes place. Amine transferase means amine group transferase. So like this, different transferases are there, and hydroxylases, hydrolysis. These includes hydrolytic enzyme which catalyze the hydrolysis of carbon, oxygen, carbon, nitrogen bond by addition of water molecule. So these are the hydrolysis. So now this hydrolysis involves in the hydrolysis of multiple bonds between carbon, oxygen, carbon, nitrogen. So here we are going to examples here. Ester is there. This ester bond undergo hydrolysis. They convert into alcohols. So lyases. These enzymes are catalyze the removal of a specific group like water, carbon dioxide, ammonia, and they also catalyze the removal of reverse reactions. So these are example removal of carbon dioxide. In here we can remove the carbon dioxide, and here we remove the double bond here, and amine group here amino acids. Here amine group will be removed. Takes place. Next, isomerases. Isomerases. These enzymes catalyze the interconversion of optical and geometrical and or positional isomers. These enzymes are catalyze the interconversion of optical, geometrical, and positional isomers. Cystans isomerization and best examples are cystans isomerization, racemations, and epimers, and interconversion of and aldol to ketosis. Aldoses to ketosis. Here double bond shifting takes place, and so here also removal of function group from conversion of function alcohols to carbonyl compounds. So these are the classification of enzymes. Next one is nomenclature of enzymes. So IUB has given the nomenclature for the enzymes in 1960. Each enzyme has been assigned a synthetic code number. Enzyme Common Commission EC, Enzyme Commission EC with the 4-digit numbers. First digit indicates that major classes of enzymes. Second digit indicates subclasses. Third digit indicates the subclasses, and fourth digit indicates a specific for substrates. For example, here we are going to discuss some examples are there. Factors affecting then the enzymatic catalysis, factor from the enzyme catalysis. So that is when we in the enzymatic reaction, if velocity of the reaction, that is a quantity of substrate transformer is plotted against time, it is observed at the first position of the curve is slightly line. Curve has been blended, that is velocity decreases and finally becomes a zero when all the substrates which have to transformed as deposited. So it is therefore advantages to measure that initial velocity of the reaction. So when we going time is increases, that velocity is increases, and at the maximum at some time the velocity becomes maximum and come to down. Okay. So factors affecting on the enzyme catalyst are enzyme substrates and physical agents like pH and temperature and pH, temperature, and oxidation potentials. So effect of enzyme concentration. Effect of enzyme concentration. If enzyme concentration is high, then reaction goes to very fast. Enzyme substrate, effect of substrate concentration. So when substrate concentration is high, reaction becomes increases at the sometimes and decreases gradually. And pH of the reactions. So the suitable pH, substrate and pH, that is a enzyme suitable pH is 2 to 8 is suitable pH for the catalysis of enzymes. And effect of temperature. So temperature increases, activity increases, but sometimes that at 40 degrees the temperature increases, the activity of catalyst increases. When we increase the 40 degrees, the activity of the enzyme is again decreases. So next one is enzyme inhibition. So enzyme inhibition is reverse inhibition and irreversible inhibitions are there. Reverse inhibitions. Reverse inhibition means when here reverse inhibition. Again, reverse inhibition two types: competitive reverse inhibition and non-competitive reverse inhibition and uncompetitive reverse inhibition. So here competitive reverse inhibition. Competitive reverse inhibition. So when we this is a enzyme, when we added catalyst, so catalyst then when we added substrate, that substrate bind the enzyme active site. When we added another mole of another substrate, that substrate will be removed first and second substrate will be form, addition takes place. This is a competitive inhibitions. Next one is non-competitive inhibitions. Non-competitive inhibitions. Here two active sites are there. So one is this is suitable for this active site, and this substrate is suitable for this active site. So only this non-competitive. Therefore this LLO steric inhibition here active site. Uncompetitive reversible interactions when substrate and enzyme complex is undergo reverse forms substrate enzyme complex. This substrate enzyme complex sometimes then after completion of the reaction they produces a product. When it is involves inhibition, then that will be removal takes place. Next, specificity of enzyme catalyzed reactions. Specificity of enzyme catalyzed reaction. Substrate, enzyme is a organic substance. Specificity is one of the main characteristic feature of the enzyme. The specificity of the enzyme is chemo-regio selectivity, enantiomeric selectivity, and prochiral selectivity and diastomeric selectivity. Substrate chemo-regio selectivity. When it is when reacting with horseradish peroxide, HRP, horseradish peroxide. So it is involves introducing of hydroxy group at ortho position of hydroxy group phenols. When we take HRP hydrogen peroxide, then again they forms ortho position of the compound. So these are some examples here we are going to share. And next one is reaction related specificity. When this compound amino acids undergo oxidation, then deamination takes place, forms alpha keto carboxylic acids. So here decarboxylation, when we remove carboxylation, and when we transamination, amine group will be removing takes place. So enantio selectivity. So here enantio selectivity. So enantiomers reactamic mixture undergo reacting with hog kidney exhalation, they forms diastomeric mixtures. Okay, we can separate enantiomer mixture from this like them. So next, enzyme inhibitions, immobilization, enzyme immobilization. So enzyme immobilization, the object of preparation of modified enzyme, that is immobilized enzyme, is to enhance the activity of enzyme, to improve the stability, to permit the enzyme to function in a changed environment, to enhance the efficiency of the process, to reduce the enzymes. Okay, these are the enzyme immobilizations. So in this topic, the major importance are one is the major important topics are, these are very important. Mechanism of mechanism of action of catalysis is very important. Next we are going to discuss coenzyme for small short answers. This is a classification of enzymes and factor affecting of enzyme activity. These three are very, very important in this chapter. Okay. Thank you.